Hi, welcome. In this video, we will solve reverse a linked list problem asked by companies like Amazon, Microsoft, Facebook, Google, Apple, and Uber.
Now let's check out this problem statement. Okay. So we are completing the linked list series. So in the linked list, the problem we have that is reverse a linked list. Okay. So basically there is one linked list given, we need to reverse it. So given a head of the singly linked list, reverse the list and return the reverse list. Okay. So you can assume that like this is type of a linked list 1, 2, 3, 4, 5. We need to return in such a way that 5, 4, 3, 2, 1. Okay. Let's quickly understand the problem statement much more better. Okay. So let's create a singly linked list. So suppose these all are my nodes. I hope some of the basic concepts of about linked list you know. So suppose this is my linked list with 1, 2, 3, 4, 5. First of all, so these all are my nodes, right? So these all are my nodes. Okay. And from these, the connection of the nodes basically is the linked list. Okay. So if my 1 is pointing to 2 and 2 is pointing to 3, 3 is pointing to 4, 4 is pointing to 5, 5 and 5 is pointing to null. This will be my linked list. Okay. And where I have one head pointer that is pointing to 1. Okay. So you can see in node we have two chambers. One is for our data and one is for address of the next node. Okay. So this is the address of your next node. This address of the next node, this is data, this is head pointer, and this is your nodes. Okay. And what I want to do, we need to reverse this complete linked list. So basically what we want, okay, if I copy this, goes here and like copy of this. This is 3, this is 4, and removing this, more all this. Okay. So what I want that I want to reverse it. That means, okay, this one should not be point to 2. It should point to null. Okay. This 2 should not be pointing to 2, right? Instead, it should point to 1. Okay. Now this 3 should not be point to 4. This should point to 2. Okay. Now 4, this should not 2.5. This should point to 3. And this 5 should not be point to null. This should point to 4. Okay, using white pen, point to 4. And I should have one head pointer to find out my head of the linked list. Right. So here you can see this is how they are pointing and this is pointing to null. So if I create it in this sense, so how it will be. So again, I'm copying this and let's see. So I don't want date in the starting. I want only the nodes. 1 node, 3 node, 4, and 5. Yeah, this is so basically how it is representing. I have a 5 here. 5 is pointing to 4, 4 is pointing to 3, 3 is pointing to 2, 2 is pointing to 1, and 1 is pointing to null. And you have one head pointer as a 5. This is how your reverse the linked list is. Okay. But how we will do it? Okay, that's the problem. How we are going to do it. So let's solve it. Let's solve it. So in the next window, so here, what could be one of the approach? So the very basic approach, if I think, okay, if I go in a very layman terms, okay, what can be your brute force approach here? Let's talk about brute force or the easiest approach that I can think of. Okay, what my friends used to do. Okay, which is not allowed in the English. So basically, what we can do here, we can store our elements, right? Like 1, then 2, then 3, then 4, then 5. Okay, in an array. So we need to take one arbitrary array, right? Normal array. We can store it and we can reverse this array. Okay. So basically how you need to store. So basically you are starting, suppose this, like you have mentioned that this is your head. Okay. And let's take one more variable. Let me put this side here. Okay. So that it is pointing to your temp, and you are simply adding temp dot data, right? So temp dot data will be one, and your temp pointer will move. Your temp pointer will be here, and you will say temp dot data will be two. Then you will move your temp pointer. Then your temp dot data will be three. You will move your pointer similarly for temp dot data. Okay. And if you reverse this linked list, it will be 5, 4, 3, 2, 1. Okay. Then what you can do? You can again start from this. You can again start from this temp pointer. And now you will take one by one element. Suppose you are at ith element 0, 1, 2, 3, 4. You can mention temp dot data equals to array I. So what you need to mention? You can mention temp dot data equals to array I, and you will run a loop from 0 to n, right? So you will move one by one. Temp will be here. You will mention temp dot data equals to array I will be 4, right? So 5, 4, 3, 2, 1. Basically, you are changing the data values. Okay. And you can solve it by using array. Okay. Again, one more similar approach. First of all, let's discuss the time and space complexity of it. So basically, what you want here, you are running an iteration that is starting from temp to temp dot data. So it will like temp to the null. So it will somehow depends on the nodes, number of the nodes, and what are the number of nodes are basically your elements. So it will be big O of n, and your space complexity will be big O of n because you are taking an extra space here of n elements. So that is also big O of n. This is how you are doing. Okay. One of the like similar approach that also some of the students try that they use is stack data structure. Okay. So instead of reversing the array, basically they will use stack here. Okay. So you can create one stack, and instead of reversing, you can mention like temp dot data first. Again, you will start from here. Okay. You will start from your temp here. Okay. And one by one, you will add the elements. So you will add one and you will move. Okay. Then you will add two, you will move. Similarly, three, then four, then five. Okay. And in the last, what you will do, you can start from here again, your temp. Okay. You can take out the topmost element. This is your topmost element. Okay. You will fill it with five. Okay. And you will move. So suppose if I fill it with five, I fill with five and I will move. Okay. And I will pop out the element as well. So I will pop out five. Okay. Now what I will do, I will fill it with my topmost element, that is four. Okay. So I will with four and I will move. Similarly, like I will pop out this element too. Okay. And there will be three to represent it. But that is not an good approach because first of all, why the time complexity is big of and why still it's not a good approach. First of all, why we are using linked list, right? Linked list is data structure that gives an efficiency of space. Okay. Efficiency of space that we are using space very efficiently, right? We are not taking any extra space. So in the arrays, there will be some leftover elements, right? So if I simply show you, suppose this is my memory. This is my memory, and in my memory, here is one element that is left, one void is created. Here, one void is created. Here, one void is created. So your linked list data structure basically use these voids, right? It connects void, right? So it connects like this, it connects like this, and this is pointing to null. This is how you are using. That's why you are using linked list data structure. Okay. But for applying the concept of linked list, you are storing again one array, right? And that's why we are using linked list to less use the space. And again, we are using arrays. So then there is no use. Okay. Your interviewer won't be happy of it because using an array and modifying the linked list, playing with your data value, it's not allowed. It's completely not allowed. There is not much sense. So again, when you are explaining this approach, you can explain like this can be the brute force and the easiest approach that I can zone. But yes, I have one optimal approach for this. Okay. Because if you come up with this answer first, there will be surely an end of the interview. Okay. So yes, For this approach, the time complexity and the space complexity will be big of n, but we will see how we can optimize it, right? We don't need to use any extra space. We are using the linked list. So let's see how we can do it. Now let's see how we can optimize it. So we'll discuss the approach to, okay, what, how we can optimize it. So the one is I will simply take out the node. Okay, I will to understand it. Okay, so let's see what we need to do. So I have one this node. Okay, this is also connecting to these nodes, right? So let's see how the structure is like this. So I have two is pointing 3 and one is pointing to 2. Okay, and we have one as an head pointer. I want to break this connection. Okay, I want to break this connection and I want to join it with 1. So yes, I can do it, right? Basically what I want this pointer, current pointer. Suppose I'm taking one current pointer that is after my head. Okay. Okay. I will do current dot next should be equals to my head pointer. So suppose I will take one pointer here and mentioning as previous. So current dot next equals to previous. But if I do these thing, I will lose this node. I will lose this node, right? How I can traverse to this node now because current dot next is not 3. Current dot next is 1. Okay. So how I will get this node, right? This node. So what I will do before current doing this current dot next, before doing current dot next, I will create one pointer to store it. I will say suppose after, right? So say I will say my after will be first of all my current dot next. Okay. My after pointer will be my current dot next before breaking it. So after will be current dot next, your after will be point to here. Then you will break current dot next equals to previous. Okay. And now you need to move in that direction. So if I want to move in that direction, so that means suppose I have one more element and that is 4. Okay. And 3 is pointing to 4. So what I want to do, I just need to move ahead, right? Because this connection is done. So I will break this connection too. So what I will do, okay, after this pointing to current, like after this here, current dot next is here, but now current will be come to here to do the things, right? So what I will do, I will say, first of all, my previous will move to here, like from 1, I will move to here. So my previous will point to current. Okay. So from previous will cancel from here. It will come here. Okay. And your current will move to after. Okay. So current will come from here and it will move to after this. Okay. Again, now these are the 4 conditions. Just my bad. Let's mention it like this. These are my 4 conditions. Again, I will use the same, right? If you can think, if we are using again, how it will be. So basically, if you are using again after now will be current dot next. So what is current dot next? This. So after will come from here. It will again mentioning here after current dot next equals to previous. So current dot next is this one. I will break this one and it will be equal to my previous. So it will previous is here, right? Now previous will be current. So previous will come from here. It will come here and current equals to after. Current will move to the after. And you can see we will move in this direction. We are breaking it and we are connecting it. We are breaking it and we are connecting it. Okay. So this is how this will work. Okay. Now let's quickly check out how we are going to write the code of it. Okay. So what will be the code of it? And or let's see. Let's first of all quickly check the code of it. Let me erase this data or let me delete it. So if I talk about for the pseudo code, okay, it will be very simple. Basically, what we want one previous that is pointing to null. Okay, then we want one current that is pointing to head my linked list. Then I want one pointer that is after that is pointing to head of the linked list. Okay, and while my current is not equals to null, current is not equals to null, I will simply move it. I'll simply move it. And how I will move it? I will move it in this fashion, that, or simply say I will simply copy this one. Okay, make it short, paste it. Because these are the 4 steps that I am going to do. Okay. After equals to current dot next equals to previous equals to current, and current equals to after, and in the last, what you will do, you will return previous. You will return basically your previous pointer. Okay. So now let's quickly see what will the implementation of the code. Basically, this will be the implementation. Okay. But I will see, like show you in the correct code. And you can see I am starting from my head pointer and I'm going till null. So basically, I'm starting from this pointer head to this null. So what will be the time complexity of this approach? Okay, basically it will, my time will depends on the number of nodes. Okay, so it is directly proportional to the nodes. So can I say my time complexity will be big O of n? Okay, not more than that. So yes, my time complexity will be big O of n. Any space complexity will be constant. I am not taking any extra space, right? No extra space I am taking here. Now let's see quickly code implementation of it. Okay, so move to the code implementation video. And after that video, what we will do, we will check out the dry run of this code. So you will get a complete understanding of it, how this is working.